Welcome to another edition of Comet Algebra. This video is for Algebra 2, Chapter 4, Section 1, about matrices. Now, matrices were used in making secret codes in World War II. Matrices are a branch of mathematics that is the basis for modern-day encryption. Programmers use matrices in programming animation. So we're going to spend a chapter studying this. It's really an interesting branch of math. So first of all, what is a matrix? We use the word array to define it, and an array is a grid of numbers. So a matrix is a rectangular array of numbers, and we write it with these bracket type of things. Each number in a matrix is called an element or an entry. And you'll notice that matrix, when we give them a name, we use a capital letter to name the matrix, which is what we will do when we're entering them on our calculator also. And then the small letter r is used to indicate each element. And we will learn how to distinguish between those elements in just a moment. So the rows in a matrix run horizontally. These two are the rows. The columns run vertically. These are the columns. And when we are asked to give the dimensions of a matrix, it's the number of rows by the number of columns. And the way I remember this is I picture the letter L. So counting down like this, we count how many rows, and then counting over, we count how many columns. So if you picture the letter L when you're asked to do the dimensions of a matrix, that will help you remember. So if we were asked to find the dimensions of matrix R here, we would count down and over. Counting down, there's two rows. So I'd write 2, and then counting over, there's 3 columns. So this is a 2 by 3 matrix. All right, let's run through some examples here, stating the dimensions of each matrix. So A, count down 2 and over 2, so A is a 2 by 2 matrix. Matrix B here, we'd count down 3 and over 2, it's a 3 by 2. This is a 1 by 4, and matrix D here is a 3 by 1. All right, a few more definitions here. We would call a row matrix one that just has the entries in one row. So like this is a 1 by 3, a 1 by 7, whatever, all the entries are in one row. Here, if the matrix is just made up of one column, it's called a column matrix. And a square matrix is just like the name indicates, the number of rows equals the number of columns, and it's shaped in a square. And we'll be talking about those more during the chapter. Now let's discuss a little more, how do we tell the difference between all the different elements? How do we indicate them? So this small letter R here indicates that it's one of the elements in the matrix named this capital R. And these numbers, what they mean is the row and column where the element is located. So the first number is the row, and the second number is the column. So we read this, it's element R, 1, 2. 1 meaning it's in this first row, 2 meaning it's in the second column. So that would be a -8. If we're looking for element 2, 1, we'd go down to the second row over, but stay in the first column rather. So that would be the element 3. Here we're looking for the element that's in the second row, third column. So go down to the second row, over to the third column, and we would find the entry of 6. Matrices have many uses, and one of the uses we will be doing in this chapter is finding the area of a triangle. Now in geometry, you had to find the height of the triangle before you could use the formula 1/2 base times height. But now, matrices, you can find this area inside this triangle, and we don't need the height. So let's just, what we're going to learn today is not the actual area. We're just going to learn how to create a matrix from the triangle. So let's assign these vertices some values. Let's just say that B is located here at 0, 6. And C looks like it would be 3, -8. And A could be over here at -7. I don't know, what do you think? -4. And this is very important that we're told to create a 2x3 matrix. So when you picture what it's going to look like, we have x and y coordinates for each of these vertices. And in order to end up with a 2x3, we're going to have to put an xy coordinate up and down below each other like this. And so I wrote this out so I can kind of picture what this is going to look like. And when we do translations, it's going to be easiest if we keep our vertices in order. So let's do vertex A first. So A, the ordered pair of A is -7, -4. The ordered pair from vertex B is 0, 6. And the ordered pair from vertex C is 3, -8. So we have created a 2x3 matrix using the vertices of triangle ABC. Today we're just interested in learning how to set up these matrices, and very soon we'll be doing things with them. All right, this last example has us creating two different matrices from the histogram that's in your book on page 147. So if you were looking at that histogram on the bottom of 147, we see that it's a graph of how much she practices her music during the 2 months. January is shown in the navy blue, February is shown in red, and it's shown the 4 weeks in those months. So again, we're just practicing pulling those numbers and creating the different sizes of the matrices that they ask us for. So I like labeling a little bit what the matrices are showing because it helps me figure out how to answer the questions that are going to come next. So if we're going to do a 2x4 matrix, I'm picturing January as the first row and February as the second row. So if you read the numbers of what she practiced for each week in January, we see that it's 5, 8, 3, and 2. And then in February, she practiced 6 hours the first week, 7 hours the second, 9, and then 4. And then if you want to label the weeks above that or below it, you can. So now we've finished half this problem. We created a 2x4 matrix. Now we want to create a 4x2. And again, if I was doing this, I like to label it a little bit so I can see that I have January in this first column, and then we can enter those numbers. And we have February in the second column. Now, we need to be able to create both of these and work with them here, kind of depending on what we were asked to do next in this problem. And after you see matrix multiplication, you'll understand why, depending on the matrix you're multiplying with, it does matter which one you choose. So now you have the knowledge you need to do section 4.1. So have fun with math.